Hello all, this is Trusha Patel. Welcome to the part 6 of macroprocessor. Next we are going to discuss processing the nested macros. While processing the nested macro, two things we have to take care about. First is for each macro we should have the different data structures. That means all the tables that we have discussed, all table we have to generate for each of the macros separately. In second, we have to maintain the counter, that is expansion nesting counter. Whenever the macro call is encountered, this counter will be incremented by 1. And whenever the macro end statement is encountered, this counter will be decremented by 1. Whenever this counter value is greater than 1, it will indicate that the nested macro call is under process, and if the value is equals to 0, it indicates that the macro expansion is ended, it is not in a progress. Now the question is how to maintain the separate data structure for each of the macro. So first possibility is we can store it in form of array. For example, we can create one array that is ap tab underscore array, and that array is consisting of all ap tab for the all nested macro, right? Now the advantage is it is very efficiently accessible, but the disadvantage is it is very expensive in terms of the memory requirement. So the second possibility is we can use stack for this. Now here stack contain the expansion records. Then what is the expansion record? Expansion record is consisting of the expansion time data for each of the macro. Now expansion record at the top of the stack is containing the data structures of the currently expanded macro. Whenever we encounter a new nested macro call, we need to push the data of that particular macro on top of the stack. And whenever we encounter the macro end statement, we need to pop the data structure or the expansion time record from the stack. So here you can see we have a stack. There are two pointer RB and TOS. RB is a record base which will point to the start of the expansion record, and TOS, that is top of stack, which points to the last occupied entry inside the stack. So whenever we are entering anything inside the stack, that will be entered at the next location from the TOS. Now, whenever we encounter a nested macro call, another set of the data structure is allocated on the stack. Now, B will point to the start location of the new expansion record, and TOS will point to the end location of the new expansion record. And whenever we encounter the macro end statement, we need to pop the current expansion record from the stack. TOS and BR both need to be reset. TOS will be now pointing to the last location of the previous expansion record, and the BR will point to the last location of the previous start location of the previous expansion record. Let us have one example. I have one call for the macro, that is computer x comma y. Now we'll start with the expansion of this computer macro. So we'll have some entry inside the stack. RB is pointing to the first position of the expansion time record, and TOS is pointing to the last position in the stack of that expansion record. Now some code will be generated. Now here pink is indicating that it's a normal statement, but here green I have indicated that this is the call of the another macro. So right now I am expanding one macro, and inside that I am having a call for the another macro. That means it's a nested macro call. Now in that case, after this area, the new expansion record will be added, that is for the INCR macro, and you can see that RB and TOC pointer are reallocated. Now RB is pointing to the first location of the new expansion time record, and TOS is pointing to the last location of the expansion time record. And the each first location of the expansion time record is pointing to the first location of the previous expansion time record to maintain the rollback. So whenever we are coming back, how we will reset our RB and TOS to the previous location. For that, this particular pointer is maintained, right? So now this INCR is again expanded by the body of that macro, and after that we have to again come back to this previous position of the stack. So this particular expansion time record of the INC will be popped out, and RB is pointing over here, and TOS will be pointing over here. So you can see that we get the same layout like this, right? And then we'll start continuing the expansion of the computer, and once we encounter the end of the expansion, all the data will be popped out from the stack. Now next is the pass structure of the macro preprocessor. There are two possibilities: single pass macro preprocessor and the two pass macro preprocessor. Now in case of the single pass, every macro must be defined before it call. Next is the macro preprocessor will alter between the macro definition and the macro expansion. That means during the processing of the program, it will do both the things consecutively. It may happen that the first macro definition is occurred, after that you have a macro expansion, then again you have one macro definition, again you have one macro expansion. So one by one, whatever is coming, macro definition and the macro expansion, both will be take care. The next is nested macro definitions are allowed in the single pass, but the nested macro calls are not allowed. While on the other hand, in the two pass macro processor, pass 1 will process only the macro definition, and pass 2 will recognize the macro calls and expand those macro calls. Now here the nested macro definitions are not allowed. So here is the end of the last part of the macro preprocessor. Thank you.